So I guess I can start. Welcome to the session on ColumnStore. We are really excited about this technology. My name is Sunil Agarwal. I'm a program manager with SQL Server team. I've been with SQL Server for the last 12 years. I've worked on ColumnStore technology starting 2014 beginning, and I'm really excited about this technology and the changes that we have done for the next release. And my goal in this talk is to bring you up to date on all the new exciting changes that we have done, and I'm hoping that you will be happy when you leave back from here about the future of ColumnStore with SQL Server team. Before I go further, just show me by raising your hands how many of you have used or are using ColumnStore technology. I see around 25% of you are using ColumnStore. So what I have done, I want to focus mostly on what we have done for 2016, but I have few basic slides to bring everybody onto the same state. All right, and anytime you have questions, I will take the questions, and if I'm running out of time, then I will take those questions after the talk. And in case you want to think of a question after this presentation is done, you can send me mail on this sunila@Microsoft. I'll be more than happy to respond and learn from your scenarios. So the overview, the agenda for this talk is actually very, very simple. I'll just give you an overview of ColumnStore technology, why do we need it, and the kind of compression we can get, kind of query performance we can get, and how do you monitor and manage ColumnStore. And what we found was in 2014, the monitoring and management of ColumnStore was not as good. There were some holes, but we learned from our customers and we have improved that, and you will see the changes. And in terms of concurrency and high availability, the changes there. And what I'll do for all these topics, I will show you what was done in 2014 and what we have changed in 2016, so you can do side-by-side comparison. So let me start with the overview. So if you look at the trends in the data warehouse, what you see here is that if you look at the chart on the side, the blue chart shows the number of data warehouses people have today and their respective sizes. This slide is a couple of years old, but it is still relevant based on my conversation with customers. So what they found was in the research that approximately 40% of the databases, data warehouses, are less than terabyte. And if you go to the bottom here, that you have approximately 17% more than 10 terabytes. Okay, this is today, and what people are projecting 3 years from now, the number of data warehouses that will be 10 terabytes or more, 34% of those customers will have that big, right? So what it means is the data is exploding, right? As a DBA or as a managing the data warehouses, you need to figure out how do I accommodate this kind of growth in my data warehouse. And as you know, as the data grows, the query performance will go down because it has to munch a lot more data. So what you're looking for is a solution that can handle this growth of the data while still delivering the query performance at an acceptable level. So the goal of ColumnStore technology from Microsoft is to provide a data warehouse for masses which can meet these kind of challenges. So what is so special about ColumnStore? So first thing to know is that ColumnStore is not unique to Microsoft. ColumnStore technology was in the academia for many, many years. All commercial vendors had adopted that technology in their product. Oracle announced with 12c last September that they have ColumnStore technology. IBM has ColumnStore technology, and we have ColumnStore technology. In fact, SQL Server came out with ColumnStore technology back in 2012, and that was our starting point, and then we are working through improving it, making it better for every release. So I think it's a good slide to see why do we need ColumnStore and what kind of benefits it can give me. So all of us have used relational systems, and we know what a row store is. So basically what it is that you have rows that are stored in full size on a page, right? On a page you can have multiple rows. The key point about the row store is that all columns in that row are stored together, right? So if you want to get column C1 and the row has say 6 columns, C1 through C6, you want to get column C1, you have to read the whole row even though you do not need those 5 columns, right? Now this kind of a solution works well in the OLTP environment because you're not really processing a lot of data. Most of the time you're saying, I want to update this record, I want to insert this row, so single row operations, and it doesn't matter. So this is actually very, very effective technology or the storage format for OLTP. Now as you know that the row store format has been used even for data warehouse. But what we are finding is as the data is growing, we are talking terabytes, right? The row store is not effective in delivering the compression and the performance, okay? And that's where the column store comes in. So, so if you have a row store solution, it's not bad, but the point is the column store takes you a few levels up in the data warehouse. And what column store is, in a very, very simplistic way, instead of storing the data as rows, we store the data as columns, okay? So you see 2 rows, if you will, like those big blue boxes. What I'm showing you is that this table has 5 columns, C1 through C5. This is not a realistic table because if you think of column store and fact tables have 30, 40, even 100 columns, right? This is just an example. So what you see under column C1, a blue box, so what we do here, at least in the Microsoft implementation, we group 1 million rows together, okay? So I take 1 million rows, and within those million rows, I pick column C1, and all the values of column C1 are stored together, okay? All the values of C2 are stored together. Now the benefit of that is, if I'm storing 1 million values of column C1 together, chances are I can get better compression, right? Because a lot of values could be very similar. I mean, imagine this, if it was a state of an employee, like we are all say living in Redmond, so Washington State, so it can compress much better, right? So that is one benefit, that I can compress much better. Then the challenge comes if I want to say select star from this table. Now it was very easy to construct a row in a row format because row is stored with all the columns. Here we have to figure out where this column for this row, where it is here. But that kind of complexity is hidden inside SQL Server, you do not have to worry about. But you can imagine if you are fetching all the columns, it will be a lot more expensive in the column store format than it is in the row store, right? So, but the thing is, when you do data warehouses, you are not really fetching all the columns. You are doing analytics on subset of columns, and that's where the benefit comes. So first benefit is, because we are storing data as column store, we can get huge compression, okay? And what we have seen with column store technology in Microsoft, you can get approximately 10x compression. So if you have a 10 terabyte data warehouse and you enable column compression, of course the mileage will vary, but expect around terabyte, okay? So that's one thing. Now the second important thing is, you only need to fetch columns that you need for your query. This is again very important, because if I was going to say, give me sum of column C1, I just do that query, select sum C1 from this giant table. Now unlike row store, I do not have to fetch column C2, C3, C4 or C5 because I don't need them, and there is no baggage for me because I'm just going to get that column. What it means is, if you assume all these columns were same size, everything was same, you are reducing your I/O 5x because I'm just getting 1/5 of the data, right? So that is huge, because a lot of data warehouses run slow because of I/O bottleneck, right? So you solve that problem. Now the third thing is, which is in contradiction with compression, if you compress the data really, really well, the query performance suffers, right? Because it has to decompress the data, construct those rows. So of course, compression on its own is not good enough if my query performance goes really, really horrible. So what Microsoft technology has done, they have special algorithms to process column store in a very effective way, and I'm going to show you some example. And with those technology, we can run those queries 3 to 4 times faster versus not without that option. So what you get out of the column store is amazing compression and amazing performance. Okay. Now these are words. I want to show you the real number. But so before I go, this is actually an important concept. So I was talking about this million rows. So if you have say 100 million row table, we will break them into units of 1 million. So there will be 100 those blocks that I'm showing you, and we call them as row groups. Okay. Now the benefit of row group is, if I was going to do a query which has some predicates, and if SQL Server knows that the data that you are interested in is only in row group 1, it does not have to read anything else, right? So the row group is a unit of the optimization that we do. So row group is a very important concept, and we will talk through some query where we can leverage that kind of knowledge. Okay. And the column that I'm calling as a segment, each of those boxes, blue boxes, are a column, right? They are called a segment. So essentially, when you think of column store, you have row groups and segments, right? So in a given row group, how many segments you will have? As many as number of columns, right? Because each, so that's the unit. And interestingly, in SQL Server, that segment actually is compressed, right? Because I've compressed 1 billion values there, is stored as a lob. So from a storage perspective, there are a bunch of lob data sitting on disk. And when you want to query, and let's say column C1 was not in memory, we will just read that lob and process the query, right? So what it means is your column store data does not have to be in memory all the time. You will page in, page out as we need, right? So I was talking about the SQL Server gives you the top compression and top query performance, and on that I wanted to share with you a benchmark that we did. This is a TPCH benchmark that was released 3 weeks ago. And the interesting thing, I want to show you 2 things which are very interesting in this one. The first of all, with the 8 socket machine. 8 socket is a big machine. Okay, we are able to process 652,000 queries per hour. That's like a huge workload from a TPCH perspective. Okay, that's one example, and we are number 1 in the industry because of this benchmark. Another thing to see here is this is running on 4 socket, right? It is giving me 404,000, and when I go to 8 socket machine, I'm getting 652. Now it is not a direct comparison here because the left box is for 3 terabyte and the right box is for 10 terabyte. But the point I'm making is the column store technology scales with the box. So if you have bigger data warehouse, buy a bigger machine, more sockets, you will see the query performance scales accordingly. That's what you want, right? So that scales. Now how does it compare with the industry? So this is 2 interesting things here. This benchmark that was released, this is on the TPCH performance results. This is a release number, and what you see here is, where is my mouse, that we are able to deliver the price per query hour is $2.43. Okay, Oracle is delivering at 4.65, which is twice the cost, right? And if you look at the numbers, we are giving you half the cost of Oracle and twice the performance. So I'm sure Oracle will come back and release a new benchmark, right? But the key point is SQL Server, you should be confident that with the column store technology, you are getting the world-class compression performance at a low price. Okay. So let's talk through basics, and there are a couple of basic slides, and we'll move into more details. So the question comes, what kind of compression do I get? I mean, people ask me all the time, hey, I have a row store table, I want to enable column store, how much compression do I get? I mean, there is no really guideline, it depends on the data. So what we have is, we have multiple kinds of compressions. So you know about row compression and page compression. This is only for the row store. Row and page compression is not available for the column store. For column store, we have a compression called column store, which is the traditional column store compression we'll talk about. You can even get even more compression by choosing an archive option. So what we have done is, if you have a partitioned column store table, which is a common case for fact, right? You have partitioned monthly, weekly, daily, whatever. You can say the older partitions, I don't query that much. I can compress them through archive, so I can get even more compression. What we are seeing with the archive, you get 20 to 30% more compression. And of course, anything I'm saying here depends on the data, so you have to measure that. Now, on that note, if you see, the TPCH is only compressing 3 times. Why is that? Because TPCH data was random generated. This is the benchmark data generated randomly, so it does not get as good a compression. But that's not the real data. In a lot of real workload scenarios, the data is, there is some commonality. You get much better compression. So with customer 1, we got 8x, some other customer we got 5x. And notice I could have put even a customer we got with 20x, but the point I'm making is it's a whole range, right? So that's what the compression is. Now what I want to share with you is how does the column store works. Like I create a column store on a table, all right? I had some data, I created a column store. But now what happens is data is being inserted, right? I mean, that's a common case. I'm pulling data from my operational system and I'm inserting the data hourly, daily, monthly, weekly, whatever, right? So how does it work? So what I'm showing you here is that a column store, we are familiar with this guy, right? This is the compressed. When I show you blue, it means compressed column store row groups, right? And what you see here is a row store. So what we do is, notice we want to compress when you have million rows together. Why? Because we get good compression. Because if you compress 2 rows together, you will not get as good a compression. You want to get larger set of rows. So the question is, how large is large? We did some experiments with a lot of data. We found 1 million is a good spot for us. So we chose that. And then you will see in terms of bulk load, we say the minimum you can go is 100,000. So if I'm loading data more than 100,000 rows together, I will compress them, okay? But our default compression size for the row group is million rows, okay? So what we do is, if you're inserting rows, they do not go to compressed store directly. We collect them. We collect them in a row group, which we called delta row group. It is hidden inside column store. You do not create a separate table. You say create column store, the delta group will be there when you need it, okay? It gets created automatically. Now when I'm inserting rows, they are landing in the delta row group, okay? They are just going like a row store. And when they become more than million rows, we compress them through a background thread. So this is what happens. I will go here. So there is the thread that I'm trying to show you is called tuple mover. It is moving million rows and makes them compressed, right? This is a thing that is running in the background. You do not have to worry about. All you're doing, inserting rows into the column store, is getting compressed, right? And the queries, when you're running, they are running both on the compressed as well as the delta row group, right? Any questions on that? Okay. Good. So now insert, when you do inserts, it always going to the delta store for the reasons I just mentioned to you. Now delete, so I'm just going to back because it comes. On the left hand side, you will see a purple delete bitmap. So what happens is when you have compressed the data, you just cannot go and remove the row because imagine it is all compressed. How do I remove the row? So what we do is instead, we create a delete bitmap. We say from this row group, this row is deleted. From this row group, this is deleted. And now what happens when you do the query, we figure out which rows should be rejected, right? So I'm also going to say if I deleted 100 rows in a row group and I do a query select some from that row group, we will remove those 100 rows from the computation. So that happens in the background. So the thing to note is that once you compress a row group, it becomes a read-only row group. All the deletes are captured in the delete bitmap, and this is actually a significant point, and we'll come to that. How do I garbage collect my rows? And we will talk about that. Now updates are done as delete followed by an insert. So when I do an update, you will see the delete bitmap showing up that this row got deleted. In fact, it was updated, so it got inserted. So any update that you do, delete from the compressed store and comes here. But if I did an update of a row that was in the delta row group, it gets deleted or updated just like a traditional row store. So there is no delete bitmap for the delta row group, just for the compressed row group. Okay. Now I want to talk about loading data into ColumnStore. There are three ways you can load the data. First is the trickle insert. I'm inserting rows one at a time. Okay. Now this is not a common scenario for data warehouse, but we support ColumnStore even on OLTP tables like operational analytics. There was a session yesterday that I talked about. In an OLTP environment, you're inserting one row at a time, updating one row at a time, right? So the data can go into ColumnStore as trickle insert. So what I'm trying to show here is those three blue things. These are three different connections that are inserting rows into the ColumnStore. And what happens is they take a X lock. So that means if I have a delta row group and I'm inserting rows, you and I, we may land up in the same delta row group. We do not block on each other. Okay, this is what you expect in a traditional row store, right? And also, if there are multiple delta row groups, it can happen. Then SQL Server will decide which delta row group I land my insert into. Okay, that's how it happens. Okay. Now the key points on this one I talked about. It is inserted into delta row group, and it is possible. Like for example, I just created a ColumnStore index. There is no delta row group. I come and insert a row, SQL Server will create a delta row group for me and get the row there, right? So this is nothing fancy here, this is how it works. And as I said, this is a common pattern for the non-clustered ColumnStore index. Now let's talk about the bulk load. In the bulk load, this is the common case for data warehouse. So what I'm trying to show here is that you have, let's say I do a bulk load with a batch size of less than 100,000. So I'm saying bulk load into this ColumnStore table, batch size is 20,000. Now as I said, we do not compress rows that are less than 20,000 if we can help it, right? So what we do is that 20,000 rows will directly go to a delta row group because we want to compress larger number of rows, right? So when you do bulk load, it will first land here, and then once it becomes million rows, then it gets compressed, which means you are adding an overhead because there are two copies, right? You copy first here, then it gets compressed, right? Ideally what you want, and this is what we recommend, that when you have bulk load into ColumnStore, you choose a row group size which is larger than 100K. When you do that, we bypass the delta row group and insert the rows directly into a new, this is the actually important point, we are inserting into a new compressed row group, right? That's how it happens. And the bulk load is parallel. You can have multiple threads hitting the ColumnStore, and what can happen is each thread of the bulk load gets its own row group. Okay, there is no blocking. And on that note, I want to show you, this is a number that we had published with 2014, I think a couple of years back. So what we saw was you could load 600 gigabyte per hour. Okay, and so it's a huge load rate on the ColumnStore index. So do you guys, let me ask you this, as your needs, do you see this load speed will be sufficient or not? Sorry, let me get my glasses. Yep, you had a question. Yes, that's right. So the great point. So any number that I show here, for example, I'm inserting, in this case what I'm showing is the gigabyte. So I mean depends of course on the college, the data types. Yes, it will depend. But I'm trying to show in the example, in fact there's a link to this paper which I'm going to send it to you guys. It was a commonly scenario based fact table and we tried that. So it is actually a huge number. Now, key point about bulk load is, of course, you can load data from external files. Each bulk load takes X log. We talked about that, and it has minimal logging. So logging is optimized. So from your perspective, whether you were loading data into a row store table, which was minimal logging in parallel, all those things are available to you in the ColumnStore. Okay. So the next thing, the third thing is also quite important, which is loading the data from a staging table. Now, why it is important? Because a lot of times you do not just read a file and push into your data warehouse. You stage it to some table, do some transformations, and then push the table, right? That's how you do it. So this is whatever I'm showing you right now. This is all 2014. There is nothing about 2016. Anything that is 2016, I'm going to highlight. All right. So now what you see here is I load data into some staging table, and I can say insert into ColumnStore, select star from the staging table. Now, of course, staging table has certain number of rows, right? If the number of rows in the staging table is less than 100,000, SQL Server will insert those into a delta row group, right? Nothing changed. And if it is more than 100,000, it will go into the compressed store. Now, the problem was a lot of customers say, can I load this in parallel? I'm running on a machine with 32 cores. I want to move data from my staging table into ColumnStore in parallel, right? I mean, you can say, well, what you do is you do restrict the set into 32 ways. It's more complex. So what we did in 2016, which is actually exciting, is we can now load the data in parallel. So if I just do insert into ColumnStore, select star from a staging table, SQL Server will do that in parallel. The parallel insert into ColumnStore is actually pretty exciting. You guys don't seem excited, but I think this is actually a pretty exciting thing. Okay. Yes, it will do by itself. You do not have to do anything, except if you do DOP1, then it will not do, right? Yeah. You can stop it, but it can do it. Yeah. Okay. So now what I'm going to talk about some new structures that we have added to ColumnStore. Okay, and it's again very interesting. So what I want to show you is this is how a cluster ColumnStore index looks like, right? What I'm showing you, the delete bitmap, the blue guys and the yellow guys, right? There could be multiple yellows, right? Because if the data is coming at a speed which we cannot compress quickly enough, right? So it can grow, things like that. And it can even happen. In fact, I'll give you a scenario. Some customer called us and their query was running extremely slow. We looked at their database and they had like 5,000 or 6,000 delta row groups. And what was happening was that they were doing so much concurrent insert and for updates and deletes, they were doing lots of updates and deletes. That was taking the lock in 2014 at the row group level. So what happens is if I'm updating a row, I have an exclusive lock at the row group level. That was the biggest problem we had with concurrency in 2014. So now if I want to insert a row, you have an exclusive lock on the delta row group. What I do? I get a new delta row group. So now you can imagine I can get more and more delta row groups. Now when I'm inserting more rows, they're getting distributed across all these delta row groups. So they are all growing, but none of them is million rows. So suddenly what you see is like explosion of delta row groups. Okay. But as I said, with 2016, we have addressed that issue. So this is how a cluster ColumnStore index looks like. Now, it is the master copy of the data. What it means is if I had a row store table, 100 gigabyte, and I say create cluster index on it, you get 10 gigabyte assuming 10x compression, and that's all you need. So that's why you can get such a huge compression. This is a master copy of the database, of the table. Now, because this is the only index, it means your analytics is simplified in the sense as a DBA, you do not have to run around and say, oh, for this query I have to have this index, for this query I have to have this index. You see what I'm saying? And the index maintenance. This is a single index, very, very powerful. Some limitations were there. This thing comes up with many, many customers I talk to. There is no primary key, foreign key constraint that can be enforced in ColumnStore today. Now, why it is important? It is important because you have dimension tables. You want to have some link of the fact table to the dimension table. So this was something lacking. And what you could do, you could enforce uniqueness using some tricks. You can create a materialized view on top of cluster column store index, but that was not as effective as if we had a native solution. We talked about that the locking granularity in the cluster column store index 2014 was at the row group level. Notice it is not at the insert, because insert is a common operation, but when you do updates or deletes, we take a lock at the row group level. Okay. Now you could argue in the data warehouse you do not do updates and deletes that much, right? Maybe true, but if you have a data load scenario which is merge based, you say merge command, right? I'm saying I have data interchanging table, I want to load the data into my column store, and the logic is if the row exists I want to modify, if it does not exist I want to insert, right? Modification means exclusive lock at the row group level, million rows, right? So that's why the merge did not scale well. So what we have done in 2016 is okay. So the column store is still the cluster column store, same, no changes. All right. What we allow, and I think this is very powerful. What we allow now is you can create your traditional. When I say traditional, I mean row store. You can create row store non-cluster indexes on cluster column store index. Now it looks very mumble jumble, right? I mean column store, row store, right? But the point is, right, if I have say 50 column table and I'll say customer ID is is a unique, let's say I say customer ID is unique, what I can do is I can create a non-cluster index on that column and say it's a primary key, okay, at the non-cluster index level, right? Now, so this is good that I can create those indexes. Now, other benefit of these indexes, now imagine I have 100 million row table, right? And I say find me a row where customer ID is so and so, okay? Now, in the worst case, because there is no index, literally there is no index on the column store table, even though we call it an index, but there is no key, right? It's just a storage format. So if I say find me a customer with customer ID so and so, in the worst case you have to scan the whole table, right? Because we don't know where it is, right? There are some tricks you can do, but for now assume there is no way. But if I had a non-cluster index on customer ID, it will have a physical pointer to the row group where that row belongs, right? Think of column store index in this context as creating a non-clustered index on a heap. When you have a heap, like the traditional row store, you have non-clustered indexes. Those index links into the table are read, right? The page and the row. It is exactly like that. Instead of page, it is a row group ID, and within the row group, it's a row ID. That's how it is. So you can imagine now, right? If I have a equality search, just give me a second. Equality search, at most, I have to scan one row group, right? And of course, you can even create a covering index, right? You can create a couple of more columns. So I think there are a lot of tricks you can do, but that's two key benefits. Yes, sir.
How will the optimizer know whether to hit the index, the clustered index, or the
Right. So if you assume optimizer is making all these decisions based on the cost. So if it is a quality search, in fact, I have a demo for you guys which will figure it out whether it should do a table scan. Because of course, if you have some cases, even though you have non-clustered index, it makes sense to do table scan, right? So it depends on that. So optimizer will hide these complexities from you. So what I'm saying here is what I just said. Now, other interesting thing, which is actually very important, because I have a non-clustered index. Now, if I want to update a row where I say customer ID so and so, and I go through the non-cluster index, NCI, I can get exclusive lock only on that index row, right? I can protect the row. I do not have to protect the row group. I can just say exclusive lock on that index row. And if you want to update the same customer, you will get blocked behind me. So what it means is now that if you are accessing the data through the index path, through the non-cluster B tree index path, you can get row level locking. Okay. And I think that is the trick that we can do with the merge scenario. You can say I'm merging a staging table into ColumnStore. You pick a row from the staging table. You say, okay, what is a primary key? Assume there was a primary key. I'm going to search, is this row exist? Does not, I insert, otherwise update. Right? Now I can do in parallel. Very, very powerful. Now, other thing, this is something I talked in detail. I just want to show a slide for completeness. So what we had was in 2012, you could create on a row store. So on a row store, which is your OLTP table, you can create a non-clustered column store index. Okay. So I imagine that you guys may be getting mixed up. There are so many kinds of combinations, but think of a OLTP workload, and you want to create a column store index on it to do analytics. Okay. In 2012, you could do that, but it was read only. So you could only do on a read only table. So it did not make sense to create that on a OLTP workload, because OLTP workload by definition is changing. Now with 2000, I'm just going to go forward, and with the 2016, when you create a non-cluster column store index, this is on the right side, it is updatable. Now it is just one line, it is updatable, but in terms of implementation, it was a big deal for us. So it is updatable, and this is the core methodology with which we are getting operational analytics. So now on your OLTP workload, you can create a non-cluster column store index. So your analytics can choose that index automatically through optimizer while your OLTP workload is running. Now the question that will come to your mind is, if I'm running analytics on the same table as my OLTP workload, how do I manage the performance? Because I do not want my OLTP workload to slow down because I'm doing analytics. And that was a session I had yesterday. So for today, what I will say is we have provided some options to control the impact of ColumnStore on your OLTP workload. And I think if you get a chance, look at the session that I gave yesterday. It talks in detail about those. Okay. Now with that, I'm going to switch to a demo. And so any questions so far, or we're doing well? Okay. I think I typed it wrong. Okay. All right. So what I'm going to do, I'm going to start with very, very simple examples. Okay. So I'm going to use a database, and I'm going to create a table. Let me first drop this table. And this is not a table that you would create in your traditional data warehouse, but for now, it's a good way to show the different functionality. So I created a table, T column store, 4 columns, and let me insert some rows. I'm going to insert only 99 rows, just like that. Okay. Now what I need to do is I want to create a column store index on this table. So I want to show you it is so simple, right? You just say create column store index on that table. I create it now. Let me run this command. It's created. It went like this because I had 99 rows. If it was big, it will take time. Yeah. So let me show you what I have in this table. I go to this table and say T column store is sitting here. And if I show you the index, it shows it's a column store, right? So now imagine this. I had 99 rows and I created column store index. Do you think those rows will be in delta store or compressed store? Any guess? Delta store. And the answer is it will be compressed, because when you say create column store index, it compresses regardless. Now one can argue it should be delta store, but it is not. It is compressed. So how do I find that out? I go to my DMVs and I can run this here is a DMV which shows me for this table, I want to see how are the row groups laid out, all right. So I'm going to go here, run this command, and it shows me that this table, this is definitely T column store, it is compressed, okay, and it has 99 rows. And one interesting property, this is something new for 2016. So the question is, when you're looking at your row groups, you will find in this case something with 99 rows, right? You say why it was 99 rows, why it is not million rows, right? And it says residual thing, that means it was part of a create index or part of rebuild. So for example, if I had a table with million and 10 rows, just making this up, million and 10 rows, it will compress million rows into one compression row group, and the next 10 will be its own compressed row group, right? It will say one is no trim and second one because of residual, because that many rows were left behind, okay. Now interestingly, in 2016 we have a thread that you can invoke through reorganize command, which will merge these small row groups into big one, because you want to get better performance. Again, this happens, you don't have to rebuild the index or rebuild the same problem, right? But the thing is that happens in the background. Okay, so that's the I wanted to show you the row group. Now if I want to see the compression on this one, let me show you the compression as well. I can go here and I say what compression do I have, and you will see it says ColumnStore, all right. So now let me do this. I'm going to change the compression. I'm going to say create cluster ColumnStore index with archive. So it's now archive, and if I run the same query, now it will show archive on the right side, right. Now of course you want to do at a partition level, the partition that is old partition, not as hot, you want to do archive there to save even more space. Okay, so now what I'm going to do is I already did this one, I can even rebuild. So change, see I changed it to archive, I'm going to rebuild and I'm going to say ColumnStore, I go back there and it becomes ColumnStore, all right. So nothing fancy there, but this is just a basic operations. Okay, now what I'm going to do is I'm going to drop this ColumnStore index and I'm going to create a non-cluster ColumnStore index, right. It just works. Now you cannot have a ColumnStore index and non-cluster ColumnStore index together, because it makes no sense. I mean, you are going to do analytics, you just need one ColumnStore index, okay. So we do not allow multiple. So now it became a non-cluster ColumnStore index, okay. So if I do a refresh here, oh no, okay, I'm going to do a refresh. There's no refresh, oh there's at the bottom, that's right. So now it is non-cluster ColumnStore, yeah, okay. Now what I'm going to do is I'm going to create one more non-cluster ColumnStore index. It fails, it says multiple not allowed, right. Now interestingly, if I insert a row, it went in. What I'm trying to show is in 2014 this would have failed, because non-cluster ColumnStore index is read only, but now it is not, right. Just wanted to show you that. And if I want to add a column, I can add a column added. If I want to remove a column, I can remove the column. So basically what I'm trying to show is the table with a ColumnStore index is just like any other table, nothing fancy about it except the storage format, right, and the query performance. Now let's look at the compression. Now the compression that you see here is amazing, right, but because it is my data, so I changed it to look good. So what I'm showing you is there are two tables I have, CI which is cluster index and CCI which is ColumnStore index, okay, cluster ColumnStore index. These two tables have million rows, okay, so let me just do that, count them. And million rows tables, that's fine. And if I want to show the space used, you will see the row store is taking 659 megabytes and the column store is taking, I get confused by this 290, and that is reserved, but the data size is 657 megabyte here and like 40 megabytes here, right? So I'm showing a huge compression, but again, this is not the real data. It's just that I wanted to show you that the row store and the column store of the same table gives you different storage, and in many cases it is around 10x storage savings. Okay, so what I want to show you now is moving data from a staging table into a column store table, and I want to show you this is in parallel. This is something new in 2016, and that's the reason I enabled the compat mode 130. Now this compat mode is a very interesting thing, and what I want to say to you is anytime a operation we have a new query plan, it is only available to you through the compat mode, because we do not want to regress customers migrating from 2014 to 16 because of query plan change. Okay, so this you have to enable this compat level flag. What I'm going to do now is I'm going to create a temporary table, and I just created the table, and I'm going to create a cluster index on it. So all I have done is, sorry, I think this exists. I hope it will say it is also okay. So what I did was I just created a temporary table with the same schema as CCI test. Okay, and I created a cluster column store index on it. Okay, now what I'm going to do is I'm going to insert 100,000 rows into my temporary column store table. Okay, and I'm running on a 4-core machine. So how many row groups will it create for me? Any guess? One. Actually it will create 4, because it is running 4 threads. It's going to get rows, 100,000 rows get divided into 4, and it will go into 4 delta row groups. Now let me see if what I said is true. Okay, it did that. I forgot to enable the query plan, which I will do again. So just bear with me. I'm going to enable the query plan. Okay, and if I show you the plan, it is parallel insert. You see that the insert is in parallel. So now I ran the command twice. How many row groups we will get? Not 8. In fact, it will add those 25,000 rows to each of those row groups. So when I see my row groups, I should see 4 delta row groups with 50,000 rows each. Make sense? Okay, so let me go here. You see that 50,000 rows? So what happens is when the delta row group got created and I insert new batch of rows, it does not go and create a new delta row group automatically. It says, is something available? Yes, I'm going to insert there. So far so good? Okay. Question? UDF, I don't understand. Okay.
Anything that stops this query from running in parallel.
Right.
So it would obviously only run in one thread, only run in one row group. So if I run a second query, so would that always hit the first row group, or would that be the
Right. So the question really is, if there are multiple delta row groups, how does SQL Server decide? It is a heuristic which is internal. There is no ordering, so it will just go somewhere. And on the question that you asked, if the select is single threaded, but insert can still be in parallel. Yes, that's, yeah. I could be wrong on this one. So, yeah, so I don't know. I mean, it's possible, but yeah, I think I actually want to correct myself. If the read is single threaded, then insert will be single threaded, because it is the same thing. So you're right about that. Yeah. Okay, the last thing I want to show you is the query performance. Okay, and okay, this is performance section. I don't want to go there. So I think this is pretty much all I wanted to cover about the basic. We have a separate section on the performance. So let me go back to the presentation, which is, I believe, 5. Yes. Okay. All right. So now we want to talk about query performance, and this is where we have done huge amount of investment. And I want to show you all those goodies that we have done here, right? So if you look at query performance, the way we get query performance is this. Some of it you already know. So let's say I have a column store table and I'm running a query, select product key, sum, where order date key is whatever, right? So first thing that you should notice that I'm only fetching 3 columns, product key, sales, and the order key, right? That means I do not have to get these 3 columns. Make sense? Now the second thing which I see is the order date key is less than certain date. And notice the order date key is, there are 2 row groups, right? And SQL Server maintains the I'm not saying it well, min and a max of the range of the date for each segment. So imagine for this one, it finds out that only this row group meets that. Imagine like there are like lots of row groups, and because I have min and max for every column, and depending on what predicate you use, I can figure out, SQL Server can figure out which row groups to read, right? So this thing is called row group elimination. Now as a performance guidance, it is in our interest to have lot of row groups eliminated, right? Because if they are not eliminated, we are bringing them in and searching all of them, right? Yeah. So in this query, I'm getting performance because of row group elimination as well as column elimination, right? This is something like a basic fundamental of the ColumnStore technology. I want to spend some time about row group elimination. Now it doesn't matter if you have 1 row group table, 2 row group table, it's no big deal. But when you have hundreds or thousands of row groups elimination is a very important concept. So what you need to do is somehow order the row groups on a column that is most commonly used. Now that is a challenge because there is no key. I mean, I cannot create a column store index and say sort by this column. It cannot be done. Even if I sort it, if I insert new rows, I can't maintain the sorted nature because I can't go and insert into compressed stores. You see what I'm saying? Now the key thing is that the most common predicate that people use, I could be wrong, but most common that I have seen is based on the date or the time, because data is coming in on the time dimension. Now if the data is coming in time dimension, it will be naturally sorted on that column, right? Because they are coming to delta store. Yes, if there are multiple delta stores created, there will be some mumble jumble, but end of the day it will be pretty much sorted. And this row group elimination is your friend. I mean, you need to see, in fact we will provide information when you run the query how many row groups were eliminated. If you are seeing row groups are not getting eliminated and you want them to be eliminated, this is a step to see why it is happening. Okay, something to watch out for. Very, very critical for performance of ColumnStore. Now the third thing, this is a magic sauce that is unique to Microsoft technology implementation for ColumnStore. What we do is, because in data warehouse we process millions of rows, right? We are not processing 1 row or 2 rows, millions of rows, right? You can say show me what happened in my sales and millions of entries, right? So instead of computing 1 row at a time, suppose I want to find average, give me in the next row average, next row average, that's slow. Versus I say give me 1,000 rows, I'm going to do the average, 1,000 rows, do the average, right? That is called batch mode processing. I'm saying in a very simplistic way, but think of this, we are processing a set of rows together. That gives us locality of memory reference, minimizes the procedure overhead call and all kinds of things. So what happens is we are creating these batches of rows, and notice the structure that I'm maintaining here. It tracks which rows qualified, which rows did not qualify. The whole thing just keeps moving up. There is no data copying going on. End of the day, when you reach to the top, you just remove the rows that have cross on it and then just give it out, right? The batch mode processing. With this processing, we are able to improve the query performance 3 to 4 times. Okay, and I'm going to give you an example where it shows that in a very clear way. Okay, so now what is new in 2016 And this is actually a very interesting problem. So batch mode processing has been supported in SQL Server 2012 forward, but it was only supported if the plan was parallel. If you were running a query and it was chosen to be run in parallel, we will leverage batch mode. Now imagine a system which is under load. There are lots of workload is running, and the query that was running before, now you run it again. It is possible SQL Server decides to choose a serial plan. Okay. As soon as it chooses a serial plan in 2014, it becomes row mode execution. It is not batch mode. So not only you got only one CPU, you got row mode. So suddenly what people saw, the performance of the query tanked. It was running fine yesterday, and today it is worse, right? So that was a situation that we wanted to resolve. Of course, we cannot control the workload that is running, but we wanted to preserve the batch mode execution. So now with 2016, if you run a query, anything that is in the batch mode will continue to be in the batch mode even with a single thread. Anybody had that kind of problem? I mean, okay, I see one hand, two hands. Yeah, so this is something we used to call this as like a performance cliff. Suddenly everything tanked, and not anymore. It will tank, of course, but not here. Yeah. Okay. All right. Other things we have done is batch mode NT semi-join. This is a very geeky term I'm using, so don't worry about it. But the point is, there are a lot of queries where say sum this thing where this does not exist here. Those kind of NT semi-join queries, we have made them run much faster. Okay. Actually, turns out that query is quite common. We have batch mode execution for multiple distinct window aggregates. Now, window aggregates is something that is very commonly used because you want to have running totals, you want to do batch processing, batch window batching. This operators or the set of operators were running in the row mode. They were not taking advantage of batch mode processing. Okay. Now with 2016, they are going to run in batch mode, and what we are seeing on average 4 to 6 times better query performance. Anybody here in the audience uses window aggregates? Okay, some of you use, and you'll be extremely surprised. And I'm going to show you some numbers with the batch mode processing, which are just insane. Now, let me see if this can go. Okay. Now, we talked about with a non-cluster index on a CCI. If I have a query, say select something from the column store where a equality predicate or a range predicate, right? In the worst case, in 2014, it would mean the full column store scan, right? Now with 2016, with the B tree index, optimizer, there was a question in the back, the optimizer will figure it out, should I use a NCI, the non-cluster index, versus cluster index, right? And of course you can play tricks. You can have a covering NCI if I'm actually fetching column on the customer ID and I get the next column all the time. You can create an NCI with one covering key column and then you're done. So this is very effective in improving the performance of short range queries and the quality search. Now other things that we have done, and I want to walk through some of those. These are actually very critical. And they are aggregate push down. So what we do is, suppose I have select some sales from ColumnStore. In 2014, what used to happen is, we will suppose the table had 10 million rows. Okay, what we will do is aggregate was computed above the storage layer. So we will read 10 million rows in batch and compute the aggregate at the next operator, right? And what we are doing in 2016 now is we will push the aggregate to the scan. So when the aggregate is pushed to the scan, the full aggregation is done there, and what you get back is actually nothing, right? I mean, everything has been aggregated. So in this example, what you will see in the query plan, 0 rows coming out of scan because everything was aggregated, and 1 row coming out of aggregate. But end result is still the same because I'm running select some sales from this table. And by doing that in the batch mode itself, we are getting 2 to 4 times better performance without doing any changes to your application. Very, very powerful. So I'm going to rush a little bit. This is pretty much what I talked about to you. And the kind of operators that we can do for aggregate pushdown is like min, max, sum, average, and it is only applicable on the types which are 8 bytes or less, and that's a very common type. The third thing that we have done is the string predicate pushdown. Currently, string predicate pushdown was not there. So imagine this. Here I'm scanning. Actually, it should be here. I'm scanning here 10 million rows, and my predicate, for example, is search. Give me rows where name is like certain thing, right? So filter happens here. So each row that comes out will be compared string wise, right? That's how it is done. Now with 2016, what we do is we push the filter to the scan. Now what happens is when you have string columns in ColumnStore, we don't store strings in a segment like full strings. What we do, we use a dictionary. Like common strings are put in a dictionary, and the segments will refer to that, right? So what we do is we compare the string, the dictionary entries for this predicate. So for example, let's say the same value was shared by 100 column, 100 distinct values of column. That means 100 distinct values of column in the same segment at the same string, all right? Now I will do a comparison whether that string qualifies in the dictionary. Once it does, then I know automatically all 100 values qualify because this is exactly the same value, right? Versus if I was going to do here, those same 100 strings will come to me, I'll compare 100 times, right? So by doing this, we are minimizing the string comparison, which is an expensive operation here, right? So with this, we are able to get much better performance for the string, and I'm going to show you through a demo. And this is the last slide I have for the window aggregates. What you see in the purple is the query performance gain that we got with window aggregates when it is running in batch mode versus blue. You can see it is huge, okay? Now with that, let me switch to demo on performance. And I have like literally 12 minutes here. So let me see how it will go. So let me kill this guy. I'm going to come and open a file with my query performance, okay? Okay, so what I'm going to do, I'm going to use the same database, and IO on, I'm going to do so that I can see everything. So what I'm going to do is I'm going to run a query, which is a simple aggregate query on CI test and CCI test, running the same query on a row store and on a column store, right? Let me run that. And what you see is, you might not have noticed, but the column store query came much faster. And let me run the query again with the query plan, okay? So I want to show you the query plan first. If you look at the query plan, you see the batch mode on the right side. That means we were able to process this query in the batch mode for the column store, and this is what you want to see. If you don't see batch mode in a query execution, you need to pay double attention why it is not so, because maybe it is not implemented, but for most operators you should see batch mode for better query performance, okay? That's one. Now other thing that you should see is the execution time, which I want to show you here. So in this case, it took 1.5 seconds elapsed, and you notice the CPU is 4.4 seconds. Do you know why? Yeah, because it is parallel plan, right? Multiple threads were running, more CPU was taken, elapsed time is much less, right? So remember 1.5 seconds, right? And if I go to ColumnStore, this is the compile, let me just go to the execution. Okay, so it is 0.122, right? So from 1.5 elapsed, I went to 0.122 for the same query, right? Huge benefit, right? Okay, so what I'm going to show you now is if I do a batch mode, if I take the batch mode out, okay? So I have this magic trace flag, okay? I'm going to turn off the batch mode processing, okay? And I'm going to run the same query that I ran before, okay? It took visibly longer, right? And if I show you the plan, it is row store, right? And remember the previous one ran into 0.122. Let's see how long this take. I go back here and right 1.075. It is still faster than the row store, but not as fast, right? So that's the key. The column store batch processing is your friend. Row group elimination is your friend. Those are the things you have to watch out for. Okay. So I'm going to turn on my batch mode processing. So I'm going to turn off this flag. It's like reverse logic, but it is turned off. Okay. Now let me go down here. So now I want to show you the impact of row group elimination and segment elimination. Okay. So if I'm running a query, I'm going to clean all my buffers. Okay. Clean my buffers. If I run the query, I'm running the same query, but in the first query I'm getting all the columns. In the second one I'm getting only one column. So which one should run faster? The second one. In the row store, it will not make much difference because you are fetching all the columns anyway, right? So let me just run that. I ran it, and if I look at the query times, you will see it did 0.154, pretty good. And if you go down here, it is 0.81, right? Of course, if you have a lot of row groups, because I have just 11 million rows, 11 million rows is nothing, you will see the difference becoming much amplified, right? The last thing I want to show you on this side is if I could do row group elimination. Okay, so what I want to do is run a query where I'm actually, if you look at the query, there are same query but running on two different tables. One is CCI test, that's the top one, and one is CCI test ordered. Okay, what I've done is I have ordered the CCI test on organizational key. Okay, so what happens in the first case, the data is not ordered. I will scan all the row groups. In the second one, if I'm lucky, I'll just scan one row group, right? So I'm going to first show you how the data is distributed in those two tables. Okay, so I go back here and I'm going to show you the range for my CCI test. Notice I'm saying column ID 3. This is the column that I'm interested in. And notice the min and the max value is 313, 313. So there is no, everything is all over the map. Okay, and if I go to the CCI ordered, I think this is the test I just saw, and if I see in the ordered, notice it is nice, 3 and 3, got it? And now if I go back to my predicate, which was greater than 12, so in the second case, CCI test ordered, I'm only going to scan one row group. You see that? Okay, so I'll go back here and I'm going to run this query. And if I look at the time, 0.119 here, and for the second one it is much lower. Now again, you're saying, well, 78 milliseconds, 120 is not a big deal. It's a big deal when you have a lot more rows. Okay, so that's that. So I actually wanted to show you more demo, but I'm going to skip. But I have a demo for the string predicate pushdown, aggregate pushdown, so you have to take my words for it. I'm going to upload these demos to the website for the conference, so you can download and play with it. Essentially, what I've seen is the string predicate pushdown and the aggregate pushdown, the performance is huge. Okay, now let me just cover a few more important slides, and then we are home free. Okay, so I'll go back to supportability. Now, things that I'm showing you in the supportability, the green is something that is in 2016 and it is superior. Any block that you see under 2016 in green, it is something to take notice of. Okay, so now, as you know, we have delete bitmap, right? Rows got deleted, they are all piling on. In 2014, you have to rebuild the column store index, either the full index or the partition, to remove those rows. With 2016, all you need to do is alter index, reorganize, which is a defragmentation. So what we will do is we will magically go back and remove deleted rows which are within the policy. I mean, if you have one row deleted out of million, we will not bother. If you have 50% rows deleted, we will compress that. we will remove the deleted rows, right? So that's huge. And I think this is a critical scenario for operational analytics, because in operational analytics you're doing lots of updates and deletes, right? And also I talked about if you have row groups with different sizes, the merge, whatever reorganize does, it can combine small row groups into big row group, right? So you want better query performance. That's that. In terms of the DMVs, we have done tons of work. I mean, trust me, I mean, this was huge for us, okay? So what we have new DMVs which can show you various states of your column store. You need to play with these things, but I just want to show you. Now this object pool is very interesting. It is tracking which segments were in memory, which were not in memory, stuff like that. So you can run your workload and then figure out, well, I'm running bad performance because my segments are not staying in memory. Because what you want is your commonly accessed segments stay in memory, right? So this is one actually the DMV that we added. Variety of X events, we have new performance counters. You can track them. And in terms of X events, what we have done is we have a separate category for ColumnStore, okay? So that's that. So I'm rushing through this one because I think this last two slides I want to go through. In concurrency, we talked about that. It's a huge change that we have made. The first thing that we have done is now you can run queries on ColumnStore index under read committed snapshot and snapshot isolation. What it means is you do not have to compromise on the consistency of the data. I mean, traditionally today what people are doing, they're running under read uncommitted because they do not want to block in case some inserts are going on, right? I mean, in a data warehouse, you're doing inserts coming on, you're doing your queries, something will get blocked, right? So now you can run those queries under read committed snapshot or a snapshot isolation. And we talked about row level locking because of beat free, right? That is there. Now the last thing is, in a cluster column store index high availability scenario, you could not run your reporting workload on the secondary. This was a limitation in 2014, okay? Now with 2016, because we have snapshot isolation, you can offload your reporting workload to the secondary. Now this is something actually is important because data warehouse more and more so has become mission critical workload, right? So people want to have always on even for data warehouse. So now what you can do is you have always on for data warehouse. Now you have two guys who can run your queries, right? Both primary and the secondary. It's a huge thing, and in fact that is one scenario we are leveraging for operational analytics. So this is all I had, and so in summary, basically what I want to show to you is that with 2016 we have made significant changes for the query performance in terms of supportability, in terms of concurrency. And if you are happy with ColumnStore, I'm positive you'll be happier when you use 2016. And thank you for coming. Yeah.